Okay, in this short little video lecture, I'm going to go through some of the pedigrees on the pedigree assignment. So this will be due on Monday, and it's posted in the Thursday Google Classroom day. So remember, I decided to do an extra credit opportunity, and that way we can have an entire work day in case kids have questions about pedigrees. So go ahead and open up the assignment and find this side where it says Genetics Pedigree Worksheet. I would prefer you started on this side because it just recaps, hey, remember pedigrees are kind of like a family tree showing how genes are passed from one generation to the next, and then it reminds you what the shapes mean, how if they are shaded in, then they have the trait that you are looking at. And then it also says that each generation is labeled with a Roman numeral. So you can see here that we have 3 generations. This is the first generation, the second generation, and the third. And then they're also individually numbered. And so this first part of the assignment, they say, hey, identify the genotypes for the following individuals using these words: homozygous dominant, homozygous recessive, and heterozygous. Okay, so individual 3, Roman numeral 3 has the trait, and I don't think it says, no, but I think you're going to assume that it's recessive, and the reason for that is the pattern. We see it affects one individual in the first generation, and then it skips a generation, and then it comes back, and that's a pretty good clue that the trait that you were looking at is actually recessive. So Roman numeral 3, they have the traits, okay? So that means that they are affected. This is a recessive trait, and so the only way to have that genotype to be completely filled in is to be homozygous. Oh, I should have just typed homozygous recessive. So if you'd like to abbreviate, you sure can, but I'm gonna do my best here to write it out. Recessive. So then for Roman numeral 2, we see that we have an individual here that is not filled, okay? So that means they carry the dominant allele. So let's just say that, we're going to use R. Let's just pick a letter, R, right? Now look at the parents, all right? So if they don't have the trait, they are big R, but if you do, you're a little r, right? Oops, Roman numeral 2, 1, sorry, this person right here. Sorry, wrong square. So you get the big R from number 2, and 1 can only give a little r, right? So 2, 1 is actually heterozygous. Heterozygous. So then you're going to do the same thing for Roman numeral 1 and Roman numeral 2 4. And then it says here, is this trait dominant or recessive? Okay, so I just kind of answered that earlier, where we see the pattern where it's in one generation, it skips a generation, and it comes back. So you're going to say recessive, and then you're going to say that it's in generations 1 and 3, but not in 2. And then you're going to go on and answer this question. So that's one side. And then number 3 at the bottom, it's asking you to make a pedigree. And they say that, here, let me get a new slide here. I'm going to read it out loud because I don't have the picture on here. New slide, hold on. New slide. Brown eyes are dominant to eye color allele, and blue eyes are recessive. A brown-eyed woman whose father had blue eyes and whose mother had brown eyes marries a brown-eyed man whose parents are also brown-eyed. They have a son who is blue-eyed. Please draw a pedigree showing all 4 grandparents, the 2 parents, and the son. Indicate which individuals you are certain of their genotype and where there are more than one possibilities. Okay, so let's start with the son, right? Let's just work our way backwards. They have a son, so there's a man and a woman. So remember, shapes, circles are females and squares are males. And they have a son. And they say that the son has blue eyes. So let's say shaded in means you exhibit blue eyes. So I'm going to shade this in. And let's already just pick a letter. You know what? I like letter B because you can tell the difference between a lowercase and a capital letter. So their son is little b, because he has blue eyes, right? Okay, so the brown-eyed woman. So she has brown eyes, whose father had blue eyes and mother had brown eyes. Okay, so her parents, here's her parents. There's dad. There's mom, whose father had blue eyes. So her dad had blue eyes. So if he has blue eyes, he's little b, little b. The only way you can have blue eyes is to be little b, little b. Mom is brown-eyed, it says. Okay. This woman marries a man who has brown eyes, whose parents are also brown-eyed. So there's dad. There's mom. Okay. Now, the boy here has blue eyes, and both his parents have brown eyes. Well, where do you get your alleles from, right? So you know that each of the parents have a little b, but they're also brown-eyed, so that means they're big B as well. So both parents are heterozygous, okay? And then the dad here, because he's heterozygous, both of his parents are brown-eyed, right? But where do you get your alleles from? Get your alleles from your parents. So one of these parents has to be heterozygous. I don't know which one, okay? So if you don't know, then you put a dash, because it could be anything, really. And so then you're going to go on and write down the mom's genotype, and then ask yourself, you know, what's the most likely genotype? Maybe you don't know. If you don't know, then you're going to put big B dash. Okay, on the back side, there are 3 more pedigrees, and so this top one is discussing Huntington's disease, okay? And when it says which members of the family are afflicted with Huntington's disease, do not forget the Roman numerals. So you have to include the Roman numerals for that. Number 2 says there are no carriers for Huntington's disease. You either have it or you don't. With this in mind, is Huntington's disease caused by a dominant or recessive? So that means if you just have one of the letters, you have it, okay? So ask yourself, is that dominant or recessive? And then I think the rest of the questions are pretty self-explanatory. The second pedigree on your assignment is looking at hitchhiker's thumb. And just based on those characteristics, there's not a lot of individuals that have it. So ask yourself, is that dominant or recessive? The bottom one, the last one on that page, which is not shown, obviously, in my lecture here, we have not discussed, but you'll see that the males are heavily afflicted with color blindness, and females tend to be carriers of that. Excuse me. So, question 12, which sex can be carriers? Well, it says half-shaded means carrier of disease. And then it says, with this in mind, what kind of trait is color blindness? It says, use your notes. It's not in your notes. So you're going to say that it's sex-linked. Okay, so 13 is sex-linked. And we can discuss more of that when we are back in class. But that's kind of the assignments. So I went through some of it. But again, we're just practicing, analyzing pedigrees, and showing how traits are passed from one generation to the next.